So this will be part 2 of section 8.6, and I'm not going to do problem 24. I just did problem 23, and they're basically the same problem. So I wanted to get into the new stuff, and the newness is we're going to start graphing more than one inequality on the same graph, and we're going to find out where their shadings overlap. So let me start with problem 26 because I think the window I have here works for problem 26. So I'm going to graph first 4x minus y is greater than 4, and then 2x plus y is greater than 12. I'm going to shade both of them, and I'm going to find out where their shadings overlap and darken that area. And the answer is technically just where the shadings overlap, and I'll talk about that in a second. So let me start with problem 26 and work on the 4x minus y is greater than 4. I'm going to find the x and the y-intercept of 4x minus y equal 4 and connect them with a dashed line. So first I'm going to plug in 0 for x. I'm going to get 4 times 0 minus y equals to 4. That gives me negative y equals to 4. I'll divide both sides by negative 1 and get y equal to negative 4. Next thing I'll do is plug 0 in for y. Get 4x minus 0 equals to 4. That gives me 4x equal to 4. Divide by 4, divide by 4, and get x equal to 1. The points I'm going to plot for that are the point 0, negative 4 and the point 1, 0. So 0, negative 4 and 1, 0. And now I'm going to figure out for shading, the point to the left of 1, 0 is 0, 0. To the point to the right of 1, 0 is 2, 0. So now I'm going to figure out, after I get that dashed line in, where I'm going to shade. And so let me draw this dashed line best I can anyways. It's a dashed line because I don't have the or equal to part. So there's the beginning of the top graph, which I'm doing in blue. The bottom graph I'll do in red just to make them stand out. Now I need to shade. I'm going to try 0, 0 and 2, 0. So now I'm going to figure out my shading. I'm going to try 0, 0, which is to the left of 1, 0. And 2, 0, I'm going to try them right in the original. 4x minus y is greater than 4. For the first one, when I plug 0 in for that x and 0 for that y, I get 0 minus 0 is bigger than 4. 0 is not bigger than 4. That's false. For the 2, 0, when I plug 2 in for that x and 0 for that y, I get 4 times 2 minus 0 is bigger than 4. That gives me 8 is bigger than 4, which is true. And that tells me I need to shade towards that point 2, 0. So when I go to do my shading, I'm going to shade the side of the line that has 2, 0 on it. And 2, 0 is over here. So I'm going to shade this whole part of this line. I'm going to shade it really lightly because ultimately I'm going to try to find out where the shadings overlap. And the parts where the shadings don't overlap really don't need to be included in my answer. So I'm doing a really kind of very minimal shading here. Done with the top one for a minute. I'm going to move on to the bottom one, the 2x plus y is less than 12. I'm going to find the x and the y-intercept of 2x plus y equal to 12 and connect them with a dashed line because I don't have the or equal to. So I'm going to plug 0 in for x and get 2 times 0 plus y equal to 12. That will simplify to y equal to 12. Then I'm going to plug 0 in for y and get 2x plus 0 equals to 12. That will give me 2x equal to 12. When I divide by 2, I'll get x equal to 6. So I'm going to plot the point 0, 12, 6, 0, connect them with a dashed line. So 0, 12, 6, 0, connect them with a dashed line. I like color coding these so I can tell my graphs apart. So the bottom one was in red. For shading, I'm going to check 5, 0, and 7, 0. So 5 is to the left of 6, 7 is to the right of 6. Now I'm going to find out for my shading. I'm going to try 5, 0 and 7, 0 because they're on either side of 6, 0. For 5, 0, I'm going to go 2 times 5 plus 0 is less than 12. That gives me 10 is less than 12, which is true. 10 is smaller than 12. For 7, 0, I go 2 times 7 for that x plus 0 for that y is less than 12. That gives me 14 is less than 12, and 14 is bigger than 12, so that's false. I need to shade to cover up that point 5, 0. So I'm going to find that point 5, 0, which is here, and I'm going to shade this coming down and to the left. So this line gets shaded that way. What I need to do is block out where the shadings overlap. And the shadings overlap right in this little kind of triangular region. So in a perfect world, I'd have been drawing in pencil, and I would have erased all the stuff here and all the stuff here where the shadings don't overlap. It's not a perfect world, and I can't erase that so well. So what we do is we highlight really darkly where the shadings overlap. And that's actually the region that needs to be only shown in our answer. I'm also asked to label the point of intersection. I'm not sure what that point is, but I can get that point real quickly. That point is on the intersection of the line 4x minus y equal to 4 and the line 2x plus y equal to 12. And I can find that point of intersection by doing the substitution method, the elimination method, or matrices. I'm going to use matrices to get that point of intersection. I'm going to enter this as a 2 by 3 matrix and do RREFA. I don't want to do any algebra to get that point of intersection, so I'm going to go second matrix, edit, make a 2 by 3 matrix. Hopefully you're pretty competent at doing these matrices by now. Enter the matrix, second quit, and then matrix math, RREF, matrix names, math, enter, enter. That point of intersection is 8/3, 20/3. That surprises me. I'm going to make sure I did this matrix right. So 4, -1, 4, 2, 1, 12, that's exactly right. So I did everything I needed to. I graphed the system of inequalities. I darkened up where the shadings overlapped, and the point where the two lines crossed, I labeled that point of intersection. So give 25 a go, and we'll move on to 27 and 28. I'll do 28. Eventually I'd like to do one of your problems. Trying to think if yours would fit in this window, and probably not so nicely. So let me start off with 28, and I'm going to minimize my shading this time to get a nicer looking answer. So first I'm going to start out with 4x minus 2y is less than or equal to 10. I'm going to get the x and the y-intercept and make a solid line for 4x minus 2y equals to 10. Really unfortunate because I'm going to get a fraction, but for me I might make it a decimal. So make my little table, plug a 0 in for x. I get 4 times 0 minus 2y equals to 10. That gives me minus 2y equals to 10. Divide by -2, divide by -2. I get a y-intercept of -5. Next, plug in 0 for y. That's the bad one. I get 4x minus 2 times 0 equals to 10. That gives me 4x equals to 10. Divide by 4, divide by 4. I get x equals 5/2. And I'm going to write 2.5. I generally like dealing with fractions, but boy, for graphing it maybe helps me to graph decimals. Let me graph those and make them with the solid line. So 0, negative 5, and 2.50. So 0, negative 5, 2.50. That's a crude estimate of 2.5 and an even estimate of negative 5, but that's good enough for me. And a solid line for these. So there's my line, 4x minus 2y equals to 10. For shading, I'm going to check 2 and 3, because 2 is smaller than 2.5, 3 is bigger than 2.5. So I'm going to go in for my shading, and into the 4x minus 2y is less than or equal to 10. Pick the number smaller than 2.5, which is 2, bigger than 2.5, which is 3. Plug 2 in and get 4 times 2 minus 2 times 0 is smaller than 10. That gives me 8 is smaller than 10, and that's true, or less than or equal to 10. And for the 3, plugging a 3 for that x and a 0 for that y, you get 12 is less than or equal to 10, which is false. So I need to shade towards the 2, 0 and away from the 3, 0. And I'm going to do a real minimal shading here. For this shading, I need to go this way. And I'm not going to do a full out shading at all because I don't really need all the shading. I only need the shading that intersects with the next shading I'm going to do. So I'm going to move on to the bottom line now. The 2x plus y is greater than or equal to 8, and start dealing with it. I'm going to find the x and the y-intercept, make a solid line for 2x plus y equals to 8. Plug 0 in for x and get 2 times 0 plus y equals to 8. That reduces to y equal to 8. Now plug 0 in for y. I get 2x plus 0 equals to 8. That gives me 2x equals to 8. Divide by 2, divide by 2. I get x equal to 4. So I'm going to plot 0, 8 and 4, 0, connect them with a solid line. So 0, 8, 4, 0, connect them with a solid line. I like color coding, so I did this one in red and this one in blue. You don't have to color code, but it helps. For shading now, I'm going to check 3 and 5 because those are on either side of 4. So now for the shading part of this, I'm going to use 3, 0, shading, and 5, 0, and plug them into the original 2x plus y is greater than or equal to 8. For the 3, 0, I'll get 2 times 3 plus 0 is bigger than or equal to 8. That says 6 is bigger than 8, which is not true. For the 5, 0, I'll plug 5 for x and 0 for y and get 2 times 5 plus 0 is greater than or equal to 8. That gives me 10 is bigger than or equal to 8, which is true. So that one I need to shade towards 5, 0. So when I go to mark out my shading, I figure out where 5, 0 is relative to that line, and it's kind of up here. So I need to shade blue line this way, red line that way. You can see, hopefully, these are the spots where the shadings overlap. And all I'm going to do is darken in where the shadings overlap. That's really the only shading that needs to be shown in my answer. And the less distractor shading that you can show, the better. So this would be the answer to problem 28. Other than I haven't labeled the point of intersection, I'm going to make a 2 by 3 matrix out of the system of equations 4x minus 2y equal to 10 and 2x plus y equal to 8, going 4, negative 2, 10, 2, 1, and 8, and doing RREFA to get this intersection point, which I bet you is a 0.31, but I'm not sure of that. In fact, it's not 3, 1 because I just checked in my head. I don't know what it is. So let me find out what that point is. Might be an ugly fraction again. So second matrix, edit. Let me get that 2 by 3 matrix in there. 4, negative 2, 10, 2, 1, and 8. Second quit, second matrix math, RREF, second matrix names, enter. Yeah, math, enter, enter. So this is the point 13 over 4, 3 over 2. That surprises me. Let me make sure I entered that matrix right. 4, negative 2, 10, 2, 1, 8. I entered it right, so that's the intersection point. All right, maybe let me do your problem 29. Hopefully it fits on my graph okay. So let's work with 29 as opposed to 30, just to get one of your problems done. If you have the confidence that you can do this by yourself, do 29, pause the video, and then see if you have it right. So for 29, I'm going to get started. I'm going to work on the 5x plus 2y is greater than 20. Do it in blue. So for the 5x plus 2y is greater than 20, I'm going to find the x and the y-intercept, make a dashed line. For 5x plus 2y equal to 20, plug in 0 for x. 5 times 0 plus 2y equals to 20 gives me 2y equals to 20. Divide by 2, and get y equal to 10. Plug 0 in for y, get 5x plus 2 times 0 equals to 20. That will simplify to 5x equal to 20. Divide by 5, and get x equal to 4. So I'm going to do a dashed line going through 0, 10, and 4, 0 for the top line. So 0, 10, got it. 4, 0, got it. Dashed line. Now for my shading, I'm going to try 3, 0, and 5, 0. So for the shading, I'm going to use 5x plus 2y is greater than 20. The x-intercept was 4, 0, so I'm going to try the smaller one, 3, 0, the bigger one, 5, 0. Plug in 3 and 0, get 5 times 3 plus 2 times 0 is bigger than 20. This simplifies to 15 is bigger than 20, which is false. Next one, plug 5 for x and 0 for y. 5 times 5 plus 2 times 0 is bigger than 20. This simplifies to 25 is bigger than 20, which is true. So my shading needs to go towards 5, 0. So I'm going to make a little arrow to tell myself I need to shade towards that 5, 0. So this one's going to shade up. That's enough for that one in terms of marking the shading, because I only want to find out where the shadings overlap and darken that. Next one, I'm going to get a fraction. So I'm going to start working on in red. I like to color code these, so I did the top one in blue. I'm going to do the bottom one in red. So for this 2x plus y is greater than 9, I'm going to find the x and the y-intercept, make a dashed line. For 2x plus y equal to 9, let me plug my 0 in for x. That gives me 2 times 0 plus y equal to 9, which simplifies to y equal to 9. Plug my 0 in for y, get 2x plus 0 equals to 9, gives me 2x equals to 9. Divide by 2, I get x equals 9 halves. And it's just easier for me to work with a decimal. So I'm going to plug 4.5 in for the x-intercept. So I'm going to plot 0, 9, 4.50, connect them with a dashed line, and then I'll worry about shading. So 0, 9, 4.50, oh boy, that's really tight, and a dashed line to connect those. Okay, for shading, I'm going to check 4, 0, and 5, 0 because my x-intercept was 4.5, and I'm going to do on either side of it. So for shading, into 2x plus y is greater than 9. The number less than 4.5 is 4. The number bigger than 4.5 is 5. So I'm checking 4 and 5, 0, plugging them into there. This first one I get 2 times 4 plus 0 is bigger than 9. That gives me 8 is bigger than 9, which is false. The second one, plugging 2 times 5 plus 0 is bigger than 9, gives me 10 is bigger than 9, which is true. So I need to shade towards 5, 0. Shading towards 5, 0 means this red line also needs to go up. So my shading is going to overlap. It's going to be a little bit tricky to see. It needs to be the further line out. So up in this part where the blue line is further out, it's going to go above the blue line. And then we're going to get to that point of intersection. And at that point of intersection, it's going to flip over and stay above the red line. So where the shadings are going to overlap is the more outside line, because both lines are shading out from the origin, because greater thans normally shade out, less thans normally shade down. When the signs are positive, that always works. So I stayed above the blue line, didn't touch up to that red line there, and here I didn't go down to the blue line because I needed to be above the red line. So my overlapping shading is above, kind of on the outside of both lines. And now I need to find this intersection point, which my graph isn't near accurate enough to tell you exactly where they're intersecting. Let me kind of do a quick 2 by 3 matrix. I'm going to enter a 2 by 3 matrix with the coefficients 5, 2, 20, 2, 1, and 9. And then second matrix math, RREF, second matrix, enter, enter. And the point where they intersect is 2, 5. That's actually where they're supposed to intersect, right about there. So that's everything for problem 29. And now we're going to move on to problems that have 4 inequalities as opposed to 2 inequalities. And they're a little messier yet, but 2 of the inequalities are easy, and then they're messier but not so bad. So 31 and 32 have 4 inequalities, 2 easies and 2 hards. I can't fit your 31 on mine, so I'm going to do 32. And to do 32, I'm going to start off doing the easy inequalities. I'm going to start off doing x is bigger than or equal to 0 first. And for x bigger than or equal to 0, I'm going to draw a solid vertical line through 0 on the x-axis, and for x's greater than, you shade right. And I'm going to do minimalize shading here because I want to find out where all the shadings overlap. So x is greater than or equal to 0 is, I find 0 on the x-axis, which is right at the origin, draw my solid line, and I'm going to shade to the right, to the right. Done with that one. I have lots of colors, so I'm going to color code these the best I can. Next one I'm going to do is y is bigger than or equal to 0. And for the y is greater than or equal to 0, I'm going to draw a solid horizontal line. These are from the beginning problems in this section. Through 0 on the y-axis, and shade up. So it's nice having colors to make the lines separate. So I'm going to shade up, shade up. If I was just doing those two inequalities, they overlap only in the first quadrant because I need to be to the right of the y-axis and above the x-axis. That's going to limit my shading to the first quadrant. All right, now for the other two. First one I'm going to do of the complicated ones is x plus y is less than or equal to 5. And for that one, for my x plus y is less than or equal to 5, I'm going to find the x and the y-intercept of x plus y equal to 5 and make a solid line because of the or equal to. So I'm going to plug 0 in for x and get 0 plus y equal to 5. That will give me y equal to 5. Then I'll plug 0 in for y and get x plus 0 equal to 5. That gives me x equal to 5. So I'm going to plot the point 0, 5 and 5, 0 and connect them with a solid line. So 0, 5, 5, 0, solid line. And then I'm going to figure out where to shade. I'm going to try 4, 0 and 6, 0 for my shading because those are on either side of 5, 0. So for my shading, I'm going to work with x plus y is less than or equal to 5. Hopefully I had an or equal to there. Yes. And try 4, 0 and 6, 0. So plug 4 and 0 for those. I get 4 plus 0 is less than or equal to 5, which gives me 4 is smaller than 5, which is true. Plug 6 and 0 in and get 6 plus 0 is less than or equal to 5. That gives me 6 is less than or equal to 5, which is false. So this blue line needs to shade towards 4, 0. So when I go for shading, I'm going to shade it. So right now, all three shadings are going to overlap in this triangular region. I have to be to the right of the y-axis, above the x-axis, and underneath this blue line. If I didn't have a fourth line to do, I would shade this triangle right here in the first quadrant because that's to the right of the y, above the x, and beneath that line. But I have one more to do, so it's going to muck it up a little bit. And let me work on 3x plus y is less than or equal to 9 now. It's nice having lots and lots of paper for this. If you try to scrunch it in, it gets really hard to follow your thoughts. So first I'm going to find the x and y-intercept of 3x plus y equal to 9 and make a solid line. So plug 0 in for x. 3 times 0 plus y equal to 9. That's going to give me y equal to 9. Plug 0 in for y. 3x plus 0 equals to 9. 3x equals to 9. Divide by 3, and get x equal to 3. So I'm going to plot 0, 9, and 3, 0. So 0, 9, 3, 0. Connect these with a solid line. Now I'm going to figure out where to shade. I'm going to try 2, 0 and 4, 0 for my shading. So for my shading, I need to try 2, 0 and 4, 0. And I'm going to try those into 3x plus y is less than or equal to 9. Plug in 2 and 0 and get 3 times 2 plus 0 is less than or equal to 9. That gives me 6 is less than or equal to 9, and that's true. For the 4, 0, I get 3 times 4 plus 0, plugging 4 for that x and 0 for that y, is less than or equal to 9. That gives me 12 is less than or equal to 9, which is false. So I need to shade towards 2, 0. So I'll make a little arrow pointing towards 2, 0, which is this way on this line. So now I need to, in my mind, figure out where all the shadings overlap. Well, I need to be to the right of the y-axis, above the x-axis, and underneath each of the lines. That means I need to be underneath the blue line, underneath the red line, to the right of the x-axis, y-axis, and above the x-axis. That's where all the shadings are going to overlap. And there's the final shaded region. That's done with the graphing part. Then it says label the corner points. So I'm going to go around the final shaded region, and any x-intercept I'm going to mark. And this point right there was an x-intercept. It's around this final boundary that I have drawn. So that's going to be considered a corner point. That's the point 0.05. This right there is an intercept of the horizontal and vertical line, so that origin is going to be considered a corner point, which is the point 0.00. That point 30 is on one of the corners of this graph. That's going to be the point 30. And then this point of intersection I'm going to find by doing RREF, which is going to be a corner point between those two equations. So let me find that last corner point by going second matrix, edit, 2 by 3, 1, 1, 5, 3, 1, 9, second quit, second matrix math, RREF, second matrix names, enter. That corner point here is going to be 2, 3. So I'm going to graph one inequality at a time, figure out how it's going to shade, but not shade completely. Find out where all four shadings are going to converge, darken that region in, and then once you have that region darkened in, any point that's an intercept or a point where lines intersect in that final shaded, or along the boundary of that final shaded region, are considered corner points. I think I might be able to help you through 33, so let me try to do 33 on this next page and not do 34, just so you can have something at your fingertips that matches with your homework. So I'm going to graph the easy ones first. So the first line I'm going to graph in 33 is x is greater than or equal to 0. To do x is greater than or equal to 0, I'm going to draw a solid vertical line through 0 on the x-axis and shade right. And again, I don't do much shading to the very end. Whoops, x is greater than or equal to 0 is perfectly. It's a solid vertical line through 0 on the x-axis. It's actually going to be the y-axis. And I'm going to shade that to the right. Done with that. Moving on to the other easy one, y is greater than or equal to 0. For y is greater than or equal to 0, we get a solid horizontal line through 0 on the y-axis, and we shade up. That's going to keep me grounded into the first quadrant because these two shadings overlap to form the first quadrant. When you get to the right of the y-axis and above the x-axis, you're stuck in the first quadrant. So my final shading has to be compartmentalized into the first quadrant because of those two inequalities. Now, x plus 2y is less than 8. Let's give that a go. So for my x plus 2y is less than 8, I'm going to find the x and the y-intercept and make a dashed line for x plus 2y equals to 8. So set up my intercepts, plug 0 in for x, get 0 plus 2y equals to 8. This simplifies to 2y equals to 8 divide by 2, and get y equal to 4. Plug 0 in for y, I get x plus 2 times 0 equal to 8. That gives me x equal to 8. That's going to give me the point 80. So I'm about to plot the point 04 and 80 and connect them with a dashed line. So 04, 80, dashed line. Notice I'm not writing the points down because it just makes it so ugly. It makes it hard to just follow your work. It's nice having graph papers and rulers handy. For my shading, I'm going to try 7 and 90 because they're on opposite sides of 8. So for my shading, less than 80 is 70, bigger than 80 is 90, and I'm going to try those in x plus 2y is less than 8. So I'm going to go 7 plus 2 times 0 is less than 8. That gives me 7 is less than 8, which is true. And then 90, go 9 plus 2 times 0 is less than 8. That gives me 9 is less than 8, which is false. I need to shade towards 70, which is going to wind up shading towards the origin. So this one going towards the 70, I'm going to need to stay in the first quadrant because the first two shadings that I did lock me into that first quadrant. And I'm going to shade down towards the origin. Last one's going to get me a fraction. I'm going to do it in red. And I'm going to get a solid line as opposed to a dashed line. So for the 2x plus y is less than or equal to 7, I'm going to get the x and the y-intercept and make a solid line for 2x plus y equal to 7. Plug in 0 for x and get 2 times 0 plus y equal to 7. That simplifies to y equal to 7. Plug in 0 for y. Plug in 0 for y and I get 2x plus 0 equals to 7. That's going to give me 2x equal to 7. Divide by 2, divide by 2. I'm going to write x equal to 3.5 specifically because it's going to help me for my shading. So I'm going to plot 0, 7, and 3.50. So 0, 7, 3.50, and I get these with a solid line. Now I'm going to figure out my shading. I'm going to check 3.0 and 4.0 for my shading because they're on either side of 3.5. So for my shading, I'm going to try 3.0. I'm going to try 4.0. I'm going to try them into 2x plus y is less than or equal to 7. For the 3.0, I'm going to go 2 times 3 plus 0 is less than or equal to 7. This is going to give me 6 is less than or equal to 7. 6 is smaller than 7, so that's true. Plugging 4 for that x and 0 for that y, I get 2 times 4 plus 0 is less than or equal to 7. Gives me 8 is less than or equal to 7, which is false. So I'm going to shade this one towards 3.0, which is going to wind up being towards the origin. So for this red one, I'm going to shade towards 3.0 and keep myself in this little box under the blue line to the right of the y-axis and above the x-axis. All the shadings are going to overlap in the same sort of shape. They're all going to be bound right in here. This is where all the shadings converge. To the right of the y-axis, above the x-axis, under the blue line, under the red line, is that little quadrilateral. We'll label the corner points. Any point along this final boundary that's an intercept or a place where lines cross is a corner point. The first corner point I'm going to mark is that y-intercept of 0, 4. I'm going to mark the origin because that's a corner of this final region, which is 0, 0. I'm going to mark that x-intercept, which is 3.50. And I'm going to mark where those 2 points cross, lines cross, by doing RREFA for that matrix that I'm going to create from that system of inequalities. So second matrix, edit 2 by 3, 1, 2, 8, 2, 1, 7, second quit, second matrix math, RREF, second matrix names, enter. I get 2 and 3 for that point. So this is the final graph for problem 33. Just a few more problems to go. I kind of like doing your homework problems just because it gives you something that you can grab onto if you get stuck. So instead of doing 36, I'm going to do 35. And I'm going to start off without writing quite so much for the first two. For x is bigger than or equal to 0, I'm going to draw a vertical line through 0 on the x-axis, which is going to give me the y-axis, and I'm going to shade to the right. For y is bigger than or equal to 0, I draw a solid horizontal line through 0 on the y-axis, which will give me the x-axis, and I'm going to shade up. Those two equations are going to keep the graph locked into the first quadrant. I have to be above the x-axis and to the right of the y-axis, and that's the first quadrant. Now, x plus y is greater than 4. That's going to be a dashed line. So when I go to work on the graphing of that, for x plus y is greater than 4, I'm going to get the x and the y-intercept, make a dashed line for x plus y equal to 4. Plug 0 in for x and get 0 plus y equals to 4. That reduces to 4. Plug 0 in for y and get x plus 0 equal to 4. And that reduces to 4. So the x and the y-intercepts are at 4. So I'm going to mark 0, 4, and 4, 0. So 0, 4, and 4, 0. Make a dashed line as opposed to a solid line. And for shading, I'm going to check 3, 0, and 5, 0. Three, 0 is to the left of 4, 0. 5, 0 is to the right. And I'm going to try those in x plus y is greater than 4. So for 3, 0, I'm going to see if 3 plus 0 is bigger than 4. That simplifies to 3 is bigger than 4, which is not true. Now I'm going to plug 5 and 0 in and get 5 plus 0 is bigger than 4. That gives me 5 is bigger than 4, and that's actually true. So the blue line needs to shade towards 5, 0, and 5, 0 is out here. The blue line, I'm going to wind up keeping my shading in the first quadrant, and I'm shading up and to the right for that one. If I was just to finish up the shading, it would be, I would shade, I would shade above this line and then to the right of the y-axis and above the x-axis. Right now, that region that I have blocked out would be what I would shade if I didn't have another line to draw, which I do. So I'm going to work on the 3x plus y is greater than 6. Do it in red. I like to do everyone in a different color, just it makes it stand out. So for the 3x plus y is greater than 6, I'm going to find the x and the y-intercept, make a dashed line for 3x plus y equal to 6. So I'm going to plug in 0 for x and get 3 times 0 plus y equal to 6. That reduces to y equal to 6. Plug 0 in for the y and get 3x plus 0 equal to 6. That gives me 3x equal to 6. divide by 3, divide by 3, that gives me x equal to 2. So I'm going to plot 0, 6, and 2, 0. So there's 0, 6, there's 2, 0. Connect them with another dashed line. Figure out where to shade by checking 1, 0 and 3, 0, which are the points on either side of that intercept. So for shading, I'm going to check the one to the left, which is 1, 0, and to the right, which is 3, 0. And I'm checking them in 3x plus y is greater than 6. So I'm going to go 3 times 1 plus 0 is bigger than 6. That gives me 3 is bigger than 6, which is false. For the next one, plugging 3 for x and 0 for y, I get 3 times 3 plus 0 is bigger than 6. That gives me 9 is bigger than 6, which is true. So I need to shade towards 3, 0, and 3, 0 is on this side of the line, so I need to be above the red line. So my overlapping shading needs to be in the first quadrant because I have to be to the right of the y-axis, above the x-axis. I need to be above both the blue and the red line. And to do that, I'm going to stay in the first quadrant, and I'm just going to butt up to the lines. And once the lines cross, I'm not going to dip under the line. I'm just going to stay to the line that's on the outside. So everything goes outside here. I stay in the first quadrant because of the first two graphs to the outside of each of the lines, and I'd get that for my region. Around this region, any x-intercept that's marked, so this x-intercept right here is next to the green shading, I'm going to mark it. That's considered a corner point. The point where the two graphs cross is considered a corner point. The point 2, 0 and 0, 4, because they're not attached to the green shading, don't need to be marked. This point 4, 0, because it's next to a shading, needs to be marked as a corner point. And then I'm going to find the point of intersection. So technically for this graph, the corner points are that point 0, 6, because it's an intercept on the boundary of my shading. 4, 0 is an intercept on the boundary of my shading. And then where the two graphs intersect, let me figure that out by going second matrix, edit, putting a 2 by 3 matrix in that has 1, 1, and 4, and 3, 1, and 6. Second quit, second matrix math, RREF, second matrix names, parentheses, enter. That point is going to be the point 1, 3, where those two graphs intersect is the point 1, 3. It even looks like 1, 3 on my graph, so I did okay. So that's everything for 35. We have a few problems left, and I told myself I was going to do your 37. And maybe we'll stop at this. There's a 39. If you want to give 39 a go, give it a go. But you can skip it if you feel comfortable enough with these. I'm not going to do 40 just because we're into a really long video already. So pause the video, try to do 37, and then check me to see if you can match up with me. So first one in 37 that I'm going to do is the x is bigger than or equal to 0. Draw a vertical line through 0 on the x-axis, and I get the y-axis, and I have to shade to the right. The other easy one for me to graph is y is bigger than or equal to 0. I draw a horizontal line through 0 on the y-axis, and I shade up. Those two shadings keep the final shading in the first quadrant. Now on to the ugly ones. So first one in blue, and then the second one in red. So for 2x plus 5y is less than 20, I'm going to find the x and the y-intercept, make a dashed line for 2x plus 5y equal to 20. Start plugging in my zeros. I'll plug in 0 for x and get 2 times 0 plus 5y equals to 20. The 0 piece goes away. That simplifies to 5y equals to 20. Divide by 5, and get y equal to 4. You can definitely do these in your head. You don't have to show this work. Next, I'm going to plug in 0 for y and get 2x plus 5 times 0 equals to 20. This is going to simplify to 2x equal to 20. Divide by 2, and I get x equal to 10. So I'm going to plot the points 0, 4, 10, 0, make a dashed line. So 0, 4, 10, 0, I had to kind of guesstimate and do a dashed line. So many times if I'm careless, I just automatically go into solid line drawing. And for this section, you'll lose a point if you get the wrong, dashed as opposed to solid. I need to check 9 and 11, which are on either sides of this for shading. So I'm going to check 9, 0, which is to the left of that, 11, 0, which is to the right of that, and I'm going to check them into 2x plus 5y is less than 20. For 9, 0, I'm going to go 2 times 9 plus 5 times 0 is less than 20. The 0 piece goes away. This simplifies to 18 is less than 20, which is true. For the 11, 0, I go 2 times 11 plus 5 times 0 is less than 20. 0 piece goes away. This simplifies to 22 is smaller than 20, which is false. I'm going to need to shade towards 9, 0, and 9, 0 is down here. I'm going to keep my shading in the first quadrant because of the first two inequalities and that I graphed. This one's going to shade towards 9, 0, which is kind of towards the origin. So done with that, moving on to 2x plus y is greater than or equal to 12. That's going to be a solid line because of the or equal to part. So last bit of shading for the video. So 2x plus y is greater than or equal to 12. I'm going to do the x and the y-intercept. Do a solid line for 2x plus y equal to 12. Plug in 0 for x and get 2x plus 0. Whoops. I get 2 times 0 plus y equal to 12. That simplifies to y equal to 12, which is going to be the point 0, 12. Plug in 0 for y. Get 2x plus 0 equals to 12. That will give me 2x equal to 12. Divide by 2 gives me x equal to 6. So plotting the point 0, 12 and 6, 0. 0, 12 is up here. 6, 0 is there. Get a solid line for this one. Now I need to check 5 and 7, 0 for my shading. So for my shading, I'm going to check 5, 0, which is smaller than 6, 0, 7, 0, which is bigger, into 2x plus y is bigger than or equal to 12. First one, go 2 times 5 plus 0 is bigger than or equal to 12. This gives me 10 is bigger than or equal to 12, and that's false. The other one, plug 7 for x and 0 for y. I get 2 times 7 plus 0 is bigger than or equal to 12, which gives me 14 is bigger than or equal to 12, which is true. So I need to shade the red one towards 7, 0. 7, 0 is above the line, so I need to shade above the line. This is tricky now. So I need to be in the first quadrant. I need to be under the blue line and above the red line. There's a really small triangle that does that. This little region right here is beneath the blue line. It's above the red line, and it's in the first quadrant. So that little triangle is what winds up getting shaded because it's the only region that is in the first quadrant, under the blue line, above the red line. For the corner points now, it's any point that's an intercept along that boundary. This point here, which is the point 10, 0, is an intercept along that boundary, so I count it. This point 6, 0 is also considered a corner point. So when I go down, if I want to write my corner points rather than just labeling them, the point 6, 0, which is an intercept around my green shaded region, as well as the 10, 0, which is an intercept, and the point where the two lines intersect, which looks like the point 5, 1, but it probably isn't, because or 5, 2 it almost looks like. Let me see what it is real quickly by going clear, second, matrix, edit, do a 2 by 3 matrix with 2, 5, 20 from the first row, 2, 1, 12 from the second row, then second quit, second matrix, math, RREF, second matrix, names, enter, enter, and I do get 5 and 2 for that point. Those two lines cross at the point 5, 2. That's the last of my corner points. Okay, that was a monster long section. I feel pretty exhausted. I just did both parts back to back. If you want to, you can try that problem 39 that I have here, but you can skip it as well. So that's the last section of material that we're responsible for. We skip 8, 7, so don't worry about it. Next thing you should do is focus on the review.